Hi everyone. So it's 3 p.m. so I guess we can start. So excited to be here today and to see a lot of you interested in micro-frontends and in my talk. And I hope that you're enjoying the conference so far. It's been really excited. So today I will talk about micro-frontends. So if you are already familiar with micro-frontends, you will probably learn something new. Or if you're not, this will definitely be interesting, and you will see what are micro-frontends, how people usually implement them, and what are some ideas around them, what problems they solve. So yeah, let's start. First thing, how many of you are still using Rails as a technology in your applications? Yeah, can you see some hands? Oh, cool, yeah, a couple of you. Cool, anyone using PHP these days? Oh yeah, just like 2, 3. Yeah, again, jQuery, so you probably remember this guy. It's still there. We are still using it, but we are trying to kill it somehow. Then there is Ember.js, so it's like old technology, but people are still using it and also creating some new applications. Then we had good old Backbone.js, so it's one of those frameworks that we want to disappear, and we're mainly recoding those Backbone.js applications in React or Angular. And there's, of course, our good friend Angular 1, and people are still remembering having problems with it. So when you tell someone that you're like using some of those technologies these days, this is probably their face. Yeah, like this technology is still not dead yet. And why are they making this face? Because we want to use something new. So nowadays, applications in general, and especially JavaScript front-end applications, are like changing a lot. We're getting new framework almost every day, every hour. So we're trying to migrate to something new, to some new technology, and to write some nicer code with some new modules. So we're using things like React.js, then Vue.js, or some new versions of Angular. But it's hard. So it's hard to like immediately deprecate some application that you have in Backbone.js and like start something from scratch. But yeah, now we can. So micro-frontend is here to help us. That's why today I want to present you micro-frontends, basically methodology or principle around web development, and show you how can you migrate from some old technology step by step, or how can you scale up your front-end applications. Something about me. So I'm Ivan Jovanovic. I live in Belgrade in Serbia, and I work for NearForm. So we're a remote-first company. Company is based in Ireland, but we have a lot of people, so probably 60–70% of people out of Ireland working remotely. And we're doing like Node.js, JavaScript applications, enterprise stuff. Yeah, there is our booth also, so if you want, you can talk with the guys that are there. Also, I'm building JS remotely, so if you're looking for a JavaScript remote job, you can find it here probably. You can check my blog and Twitter. I'm writing usually about those things, or reactive programming and JavaScript in general. So enough about me. Let's jump on micro-frontends again. So what are micro-frontends? As the title said, it's just a microservice approach to the modern web. So here we see this microservice word. So for the people that are not familiar, what are microservices? This is simple sentence from Wikipedia. So microservice is just architectural style that structures your application as a collection of loosely coupled services. So we have application that's basically created of some small loosely coupled services, meaning that they can be independent, so they're not dependent on each other. They can work independently, but together they create a bigger system. Since I'm doing JavaScript, this is how it works in Node.js. So just a simple example, we have one big application created from 3 small microservices, and they're like working together and exchanging some data and serving that to the user. If you want to make them like loosely coupled, this is how it can look like. So we usually have some Eventbus that's used for communication, so for exchanging some data between those services, and then we have 5 Node.js application that just send some data to Eventbus and then receive that back. Eventbus just allow us to have that publish-subscribe style of communication between components without requiring them to register one with another. So they don't know who else is registered in the Eventbus. Every service just connects to the Eventbus and works with it. What are some principles of microservices? First thing is that we need some lightweight protocol between services. Something that's simple, people usually use those event buses, or they just use HTTP REST protocol for their services to communicate. Then we want small services. So since we are splitting our big application, we want to create smaller parts that do just one job and do that perfectly. Then we have those service independencies. Every service is independent. You can run it alone, and you can put some data inside. You expect some data to be returned. Then microservices should really be easier to understand, develop, and test. Because when you have one microservice, you can create a really good documentation for that microservice. So anyone else that just pulls the code from Git can just read documentation immediately, know how that service works and where are things in the service, so you can easily develop some new feature, add something on top, and also write some tests, because when you have small application, it's really easy to just write some tests for a specific part. It should also speed up development. So when you have smaller things, you can just, as I said, take that one small app, work on it, and then just move it back on the system. And also, this really enables us to have the continuous delivery and development and deployment. So whenever something is ready, you can push that, send that to the web, to the server. You don't need to wait for those long builds that we had with Rails and PHP apps. I was working in a company where we had like 50,000 tests, and the whole build took almost whole day. So if you have some fix to deploy, you will need to wait for all those tests to pass, for the whole build, for everything, for migrations to run, and so on. With microservices, you just need to update that one service and deploy that service. So that should take like a couple minutes or even less. So let's go back to the previous picture where we had Node.js microservices. This is what we have on the back end, but imagine having something like this on the front end. So this is React app created from multiple smaller React.js applications. That sounds really fun, but we can do even crazier things. We can have multiple frameworks running at the same time in the browser, running multiple front-end applications, and all of them are like serving one user experience. So from like, you probably read some blogs like which one is better, Angular, React, or Vue, which one should we use? We can talk more about how can we use them together. So like Angular plus React plus Vue.js, how can we use the benefits of all three and everything that they give to us, and how can we create really unique user experience by using all those three technologies. So with micro-frontends, we have microservices everywhere. So the same way we have microservices on the back end, we can have them on the front end, being developed, deployed independently, working independently, and doing that one job correctly. How this really looks in a real life. So imagine having like one application with 3 features, and we just split those features into separate applications. So we have feature 1, 2, and 3. And for each of those features, we can create separate app, as I said. So any of those apps can run in any different framework, or they can just use jQuery, and they can serve their own user experience. Like usual example is like if you have like e-commerce app, you have list of the products can be one app, cart can be, or basket can be another, the whole order process can be another, the user profile can be another app, and then you can split the application and have multiple teams working on separate parts of the whole flow of your e-commerce app. As I said, we want to achieve microservices everywhere, where we have the root app being served, and that root app is created from multiple applications running on the front end, and then multiple microservices, so back-end applications running on the back end, where each front-end service has its own microservice in the back end, and they together do that one thing properly. So if you have e-commerce app with basket, app 1 will be basket, and microservice 1 will have a database for basket, and it will help app 1 serve to the user. This really looks nice, but how did we get here? We're now talking about having multiple real applications running in the front end. So what happened in the past? We had multiple, we have monolith full stack apps, so like PHP or C# or Rails apps, that they were doing one thing. So you would deploy the app on the server, and that app was serving HTML to the browser, and you had everything on one place. And then we saw that it's a bit complicated. When you started scaling, you get more and more developers in the team. So we split up things into front-end and back-end apps. So now we have front-end and back-end developers specialized in that one field. Then we saw that when back-end scales, we want, and we have a lot of developers working on that one monolith app, we split that up. So we have microservices in the back-end, where like every service has its own team or a separate server where it's being deployed. And then we got React.js, so a couple of years ago, where they introduced components in the UI. So it was one starting way to implement to split up application in some way into components, where we could have like component libraries that are developed by separate teams, and then we bundle that into one big React app and deploy it to the web. And now we have micro-frontends. So components were not enough. We really want to have independent applications running on the front end. So that's why today we're talking about micro-frontends. We're doing all those changes because we need to fight with the bad architecture. I was working on multiple companies over my career, and each of them had the same problem. So architecture was always bad. When you start scaling, they usually start small, having like a couple people working on that specific app, and it starts scaling more and more. They get some investment, and you have, in no time, you have like 100 people working on that one app, and you start adding more tests, more features, and then in no time you have 50,000 tests with hundreds, thousands of features and 2,000 people working on that one app. And you started losing clients because it's not stable anymore, and now you try to fix those things. So we are always fighting with those tech debts, and we are fighting with the bad architecture. So in the fighting with bad architecture, how can micro-frontends methodology help here? First thing, as I said at the start, we all have some old architectures, and we're paying the tech debt. So with micro-frontends, we can start with something new and fresh on top of that older technology and older architecture. With that Rails app that I worked on, we started implementing micro-frontends, where for every new feature that was like bigger, we started implementing a React app that was running on top of it, and it helped us to move somewhere and start splitting up the whole app. Then with micro-frontends, you don't have shared code bases and conflicts anymore. So if you set it up like that, where every micro-frontend has its own repo, or at least you have one repo with a specific directory for every micro-frontend app, you won't have any conflicts anymore. Like someone else is working on some other feature, but it's in conflict with yours. That shouldn't happen anymore. Then independent deployments. So right now, everyone is just having one deployment for the front-end application. That can take some time, depending on the size of the app. With micro-frontends, you can solve that, where every micro app can be deployed totally alone on a separate server without touching other pieces of your app. And a good thing, or sometimes even a bad thing, every team can pick their own stack. So if you don't control that, it can be a disaster. If you have 20 teams and each of them picks their own front-end framework and code style, it can be a problem. But Micro-frontends gives that ability that you can talk with people and then they are able to use something new or whatever they want. And yeah, you can finally scale your front-end app. So as it grows, as you create your development team, you can, again, have the same speed of development and have the same user satisfaction. How to split applications. So we saw what is micro-frontend and how it works. So how you usually split your big app. First thing is always is by functionality on the page. So as I said, if you have one page with multiple things going around, you can split those big features into smaller apps and then have one separate app running that specific feature. Or by page. So you know that sometimes having multiple front-end applications running at the same time in the browser, they can crash some older devices. So it's the safest way is to split by page. So if you have good routing, you can run separate specific micro app for every page. And that will also be good for your developers. They will always work on that one page, on that one functionality, and your users won't really feel that. And also by section. So I saw that people split sidebar and the main stuff into separate apps. So you can do whatever you want here. Yeah, now the fun way. So this was a brief introduction how we work with micro-frontends, what problems we solve here. But let's see how this really works. So what are some ways that we have now that you can start using immediately? First thing, it's external app bootstrapping, not really a name. It's just something that I created in one company. So one flow of developing micro apps. Then we have our good friends, so iframes. They exist here since the 90s, and we're just using them in a different way now to solve some different problem. Then we have single SPA library. So it's a JavaScript library created specifically by one company for their own needs, and then they open source that. And now we can use single SPA to help us develop and run micro apps. And we have Frint framework, so it's really a framework that works with React, and Vue.js, and it helps us really bootstrap and have the router and everything inside for working with micro apps. So now we'll just go through each of these and show how they work. First one is external app bootstrapping. So what are some features that this gives us? First is that code lives on a different server, so you can deploy bundles of your apps on different server and then have that one main root app bootstrapping the code from different external web servers. Then independent deployment, of course. If you have different servers, you can create a separate CI for deploying the code there. And for communications, of course, you need to have some way to exchange data between your micro-frontends. So you won't always have all the data on the microservice that, for example, is living on the back end and your micro-frontend is communicating with. You will need to exchange some data like session tokens or something between your apps. So for that, we can use window object, so it's it's always in every browser. And we can use some implementation of the front-end Eventbus. I will show later how that looks like. So this is how code looks like. I will zoom in on each part. But basically, this is a function called fetchApp, and it's used on your main root application. This is so 26 lines are enough for you to run for every micro app to pull the data and to bootstrap that one app into separate div. So this function is just taking element, base URL, and the list of files. For every micro app, you will need to say where you want to bootstrap that app, what's the base URL of the server where your external code is living, and what are the files that you want to use. So it's usually main.js and main CSS. So when we zoom in, this is main part. We just go through those files. So if we have main CSS, main.js, or if we do code splitting and we have some different names for files, we just go create a file URL for every file, and if it's a JS file, we just inject that in the browser. So this example is just using Ajax from jQuery, but you can use Fetch or whatever else. And we just inject that into the browser. And if it's a CSS, we just create a link element that links to the CSS of that external app. And that's basically it. So with this, you can store main CSS and main JS files across different servers and have the root app bootstrapping that. Also here, you can see on done. We're injecting also inside the global object of the browser, we're injecting a function that's coming from the micro app that just we send the element to the micro app where we want to bootstrap that micro app. So you will see it will be more clear here. This is an example of the React application that's like micro app that should be bundled and stored on the external server. We're here exporting a function. So that function is basically this one, so global function name, and it's accepting element. So the element should be the place ID of a div or anything else where we want to bootstrap that app. And we're just rendering our React app into a div that's being sent by the root app. And then on the index.js, the main export, we just need to inject that function into a global object. And this is the only change that you need to make on your external app, just to inject the function in the global object, and it should work. Now, if we deploy our React app on a different server, on main root app, we just need to use fetch app to bootstrap the React app. So we just pass element, so ID of the app, ID of the div, so it's hash app, and the base URL, so what's the place where the main JS and main CSS are living. And this is also, when this is executed inside div with the ID app, we will get our React app running. Simple as that. This is the first implementation, so I wrote this code, and it helped us to just start implementing micro apps on some older technologies like Rails or PHP. So you just need to run this on the front end, and that's it. Now I said that there is Eventbus implementation, so it's called EEV, and it's open sourced on GitHub. And the cool thing is that it's really small, so it just has, it's basically a class that has two methods to be used, and it's really fast. So it has around 100 lines, so it makes it really fast. And it doesn't have any dependency, so you will just install EEV and nothing else. And it's really, really simple to use. So as I said, you can find it on GitHub, and it works like this. So you just import EEV from Node modules, and you just create E object from EEV. And this E object has emit and on, two methods. If you worked with microservices in the backend, this is probably familiar to you. So with emit, we can emit any event. In this function, the first argument is name of the event, and second one is data that we want to send. And there is on function, which is just waiting for that event to happen, and it does something with it. We just need, with the first implementation and probably with the others later, we just need to share this EEV object. The simple way is just to put that in the window, and then the service that's sending some data can just call window.e.emit, and the one that it's receiving data can just call window.e.on, and when data comes, the callback function will be executed, and you can do whatever you need inside your app. Which is really simple and fast way to use Eventbus and something similar that we have on the back end, so you can use it in a simple way now on the front end. So this was the first implementation of micro frontends. Now something interesting, it's iframes. So how can we use iframes to create a micro frontend architecture now? First thing, something about micro frontends is that, something about iframes is that same way here, code is living on different server, obviously. And again, we have independent deployment. But something that's different here is how to communicate between those services. So you have service running inside the iframe, so from a different server, and then you have the root app that's just bootstrapping that iframe. So there's something called, I call it like browser Eventbus, because it works in the same way, but it's basically post message. It's here for a long time, but we're now using it in a bit different way. So it's working the same as EEV or any other Eventbus implementation. We can just send some message to the iframe, and iframe service can send that message back. And we can have event listener, so in the root app or in the server, in the service, that's just waiting for the message to be sent, and also receives a callback. So we always here wait for message. There is no way to send the other name of the message, but you can send a specific message to a specific iframe. So that's how you can tell, like, send to app 1 or app 2 or app 3 this data. And example here is like one big HTML file, but at the bottom you see here that we have iframe and some big JS code. So I will zoom in into the JS code. It's really simple. When the iframe is bootstrapped, we can just get a reference from the iframe. So get element by ID, and we get the content window. So we get what's inside, reference to a thing that's inside iframe, and then we can post messages. So we can send messages to, for example, google.com and example.com. First one won't work because our iframe is running on example.com. So you need to say what's the base URL of the iframe service, and then when this first one will fail, second one will work, and then other lines here are just waiting for, so window.event, add event listener is just waiting for some message to be received back from the iframe, and then there is receive message callback. So it's here, we're just console logging whatever we get from the iframe, and there's just one check. So we want to be sure that this message is coming from example.com, so the place where the iframe is, so the place that iframe boosts. Otherwise, if we don't have this check, anyone else can just post message to our app, and it can be hacked. So we need to be careful with this. And in the same way, we have the code in the iframe. So this is what should be running in the iframe. Again, we have the event listener. We check that the origin is coming from the correct place. And then here inside event.source, this is a reference to the root app, so the app that's bootstrapping iframe, and we can post message back. So in this way, with post message, we can exchange data between iframes, or between root app and the iframe. And using iframe is just simple. You have any app running on the separate server, you just put the URL of that page in the iframe, and that's it. You don't need to set up anything, and it's really simple to work with. A lot of companies are using this approach, so I will talk more about that later. Next thing after iframes is single SPA library. So first two were like some kind of hacks that we now use in a bit different way for micro-frontends. Single SPA is a specific library created for micro-frontends. So it's written in JavaScript, open sourced, and it's created mainly to help us work with micro-frontends. As I said, it's open sourced, and Canopy.Text is the name of the company that created it. And it's helping us to use multiple frameworks on the same page without refreshing the page. Then we can write code using new framework without a need to rewrite our app. So you don't need to change. If you have one React app and you want to use it with single SPA and add one more React app, you don't need to change anything in your already written app. You just need to add one more file that will make a connection between single SPA and the app. None of the changes are required. And a cool thing is that we have lazy load implementation here. So with first two implementations, when the user comes to a page, you will download a lot of JavaScript and CSS code in the browser. With single SPA, you can tell the browser when to download which part of the code, which is really cool. You have some kind of scrolling. If your micro app is somewhere below the user viewpoint, you can have on scroll event saying that when the user scrolls to the app, load it then and have some faster and nicer implementation. It's on GitHub. You can check it out. There's a bunch of documentation and examples. And what about single SPA here? The code here is living on the same server, so that's a bit different. They have some documentation how can you make it running on different servers, but with initial implementation, the code is always running in the same server with one bundle. So with your multiple applications, you will need to bundle them and deploy them at the same time. But beside that, there are a lot of cool things that you have different ways of communication between your services. You can, again, use window object. You can use EEV, Eventbus. But then you can use some shared state modules like Redux or MobX or whatever else. And yeah, basically whatever else is working for you, because this is just JavaScript code, so no hacks, no anything. You bundle everything together, so you can use any module for sharing state between your apps. Single SPA is really simple to use. So you just import that. You create 3 functions for your micro app, and you just call single SPA start. Also, for every application, you need to declare child app. So there is app name that you need to send. You need to send loading function and activity function. And when you declare your app, you just need to start it, and that's all. So app name is just a string. Let's go now to see what's a loading function and activity function. Loading function is just returning, so a function that returns a promise that resolves on a place where with the code from for that app. So here we're just importing app.js, so the code of bundled code of your sorry, not bundle, it's the code that's the file that's exporting the root app of your child app. And activity function is where we implement lazy loading. So activity function is saying when it returns true, it means that single SPA needs to bootstrap your app. If it returns false, then it unmounts it. And here, for example, a simple router is created. So we have a location history API here, so we can see the location, current location of the app. And if the URL starts with #/app1, this will return true. So single SPA will call loading function, and it will load the code, bootstrap everything, mount into a browser, and the user will see it. Here we can do like window on scroll event or wait for something else to happen before you bootstrap your app. And yeah, so at the bottom we need to, for every child app, we need to use declare child application function to declare the function and just to start the single SPA. That's all. This is what we need on the root app, but those are some changes that we need to create on child app. So every child app needs to export 3 functions, so bootstrap, mount, and unmount. Bootstrap is used to like prepare DOM for rendering your micro app. Here we're just creating like a div with ID app1. So it prepares HTML code for rendering your app. Then mount. So when the loading function returns true, this code will be executed. And in this example, just we put some content inside div. But basically, React or Angular or Vue.js will just render content inside the div. And unmount, so when the false is returned from the loading function, this will be executed, so you need to remove everything from the div and clean up the code. So as I said, if you already have some application, you need to make some changes, you just need to add those 3 methods. If you're running React, Angular, or Vue apps, there are already modules for that, so single SPA React, single SPA Angular, single SPA Vue, that will help you create those bootstrap mount and unmount methods. So here, like we create an object with React DOM and the root app, and also the place where we want to render the React app, and you're just exporting those three. So really simple to integrate any app with a model framework in the single SPA. With Angular, it's almost the same. So we need to pass main module, the Angular platform, the template that we want to render, router, the place where we want to render Angular app, and we get Bootstrap mount and unmount easily from there. And Vue.js is the simplest. So you pass view and you pass the location of the so the div where you want to render the app and the template that you want to render, and you get Bootstrap mount and unmount. Also, for some other frameworks, they also have a single SPA dash name of the framework that you can use to integrate any other framework with the single SPA and create a really nice environment. And the last one of the implementations is Frint. So Frint.js is they have a website, so frint.js.org. It's a framework because it has a CLI, it has routing, it has state management, it has server-side rendering, so it's really more advanced than single SPA or any other previous implementations. It's a bit different that might be harder to integrate something that you already have with Frint, but if you're starting fresh, you can use Frint CLI with just a couple lines of code. You set up everything, connect everything, create your apps, and then you can just easily add Redux, or Redux is coming with it, so you just need to enable that, and you get server-side rendering out of the box with it, which is really cool. And this is their website, so they say it's modular JavaScript framework for building scalable and reactive applications. So if you're also in reactive programming, they're natively supporting RxJS, which is really cool. I will just show how CLI works. So if you install Frint CLI globally, you can just create a new project. So we're just creating kitchen sink example here, but you can just create a new object and then Frint new app. You can create new apps and connect them, which is really simple and really fast, and you can start in no time. At Frint, as I said, reactive programming is coming out of the box, so if you want to use streams, that's already there, so you don't need to install anything. And also it works with React Native, so if you want to use microfrontends on mobile devices, that's possible with Frint out of the box. So you can create a React Native app with Frint.js and having smaller apps running at the same time on your mobile phone as a native app, which is really great and sounds crazy. So we're almost there. I showed you 4 different ways of implementation. There are a bunch of more people are writing books now about micro-frontends, so it's a thing that's really growing, so you can find a lot of examples online now. And we also talked, what are micro-frontends, what are the pros, but what are the cons? Of course, every methodology has a lot of cons, and one of the cons of micro-frontends is that you have more code and more dependencies to maintain. Of course, when you start implementing smaller apps, there's a lot of boilerplate code that you need to take, also a lot of dependencies. Even like if you have 10 React apps running on different React versions, there will be a lot of mess there and a lot of dependency that you will need to constantly update and check. Then you can create big bundles. So with single SPA, for example, if you have 10 apps, they will make really big bundle that will be executed in the browser, and it might slow your app. Because of those big bundles and also performance issues, because when you have a big bundle and a lot of code in the browser, it can be really slow. At the start, I said that a lot of companies are splitting up the app by page. This is like main reason, because when you split the app by page, you don't have all micro apps running at the same time, so your browser experience will be much faster. So as you see here, it's like mainly performance, but people are working on it and creating new stuff, discovering things. So I'm sure that performance issues with micro-frontends will definitely change in the future. who's using micro-frontends. So it's a fun new technology, and a lot of companies, especially bigger ones like Google, are starting, or they're using it for years, but they probably called it differently. For example, on Google, if you go to Gmail and you have Hangouts on the side, Hangout chat, it's running in the iframe, so it's one way of implementing micro-frontends that they do. Or like Microsoft, if you go like to Outlook email, and even like some of the pop-ups that comes up when you like hover the name of the sender and you get his email and picture and so on, that's like React app that's separately developed and bootstrapped there, and they have like 60 people working on just that one pop-up. So this is their way of implementing micro-frontends. Then there's Facebook. So in Facebook, even like and share buttons are separate React apps that are like bootstrapped in the UI. Then there's Dozens. So you can also check Dozens website. They're creating really cool things, and they're writing a lot about micro-frontends. So they're using it for their streaming platform. So they're creating something like Netflix for sports. And they have a lot of users, a lot of scaling, and they're solving front-end issues with micro-frontends. And also Salondo, so they're, I think, one of the first that started open sourcing stuff for micro-frontends. So for Zalando's e-commerce app, they're using a lot of micro apps there. And yeah, many more companies. So nowadays, everyone that's scaling more than like 100 developers, they try to implement smaller micro apps on the UI to try to solve front-end scaling. Conclusion. So what we talked about today and what we learned, first thing is that you don't need to use this if you have simple apps. So I said when companies start growing 100, 200, 300 developers, front-end developers, they try this. If you have a small team with a couple developers, this will just make more problems to you because you will need to maintain much more code and much more dependencies. And also, if you have like small team and small app, when your app starts growing, of course, you can try this out. And use micro-frontends to make things and develop it easier, not complicated. So be careful there. It's really easy to like make mistakes and try everything that's there on the web, and then create a monster of many micro-frontends with different frameworks and methodologies and everything. And this doesn't mean that you need to use and put a new framework on top of your app every day. So be careful with that. And you also need to make standards across teams. So if you give responsibility to every team that they can build and develop their separate apps, just make standards across there so they don't start using anything that's available. That's all. Thank you very much.